Hi friends, we'll see today's title as Utilization of Electrical Energy. You know that the electrical energy is utilized in household appliances, industrial, and everywhere you can see this electrical energy is the ultimate. So the utilization of electrical energy is very important topic in our electrical engineering. And we can see the illumination is the main content in our utilization of the electrical energy. So what we are going to see in this video, and you are seeing the introduction to the lighting illuminations and the nature of light, and what are all the terminologies used in this illumination, and what about the laws of illuminations, and what about the electrical methods of producing light, and what about the source of light, how the light will be ignited, and also the types of lamps: arc lamps, filament lamps, gaseous discharge lamp, sodium vapor lamp, mercury vapor lamp, and fluorescent lamp, neon lamp, halogen lamp, and compact fluorescent lamp. So these are all the examples of the various types of lamps, and also how you are going to measure that light. So we are measuring in this candle power. So what is called the candle power, and how it is measured, and what about the lighting schemes. So in our day-to-day life, the lighting schemes are very important. How you are going to calculate the lighting schemes, and what about the types of lighting schemes. Mainly we can classify into street lighting and flood lighting are the major lighting scheme in our life. So the illumination title we are going to see one by one. So we can segregate into four titles: introduction, nature and the production of light, sensitivity of the eye, and also the units of light. As we know, the light is uh, almost all human activities depends upon the light. So the light may be uh, divided into two. One is called natural lighting, another is called artificial lighting. So the natural lighting, in the sense, the sun is the ultimate because it is the main source of light. But in the artificial light, we can go for any concerns or institutions or industries. Wherever we are going, artificial lighting is the plays a very important role or a significant role. So it plays an almost a main role in our daily life. So how these artificial lights are produced? So in this case, the mechanical lamps as well as the electrical lamps are the main source of this artificial light. But due to poor performance, the mechanical lights are totally replaced by electrical lights. So now the electrical lighting only will play a main role in our daily life. So what is called electrical lighting? So the electrical lighting are mainly used for decorative purpose, advertising, traffic control, medical field, and also some extra, and even the street lighting schemes. So it is the plenty of usage for artificial lighting. And increase in temperature produce an increase in the amount of both kinds of radiations. That means heat and light are both we are producing, but the color of light or visible radiation changes from bright red to orange and to yellow, and then finally, if the temperature is high enough, it is to white. So as temperature is increased, the wavelength of the visible radiation goes on becoming shorter. It should be noted that heat waves are identical to light waves except that they are of longer wavelength and hence produce no impression on the retina. Obviously, you know that from the point of view, the light emits energy represents so much wasted energy. And what are the advantages of this electrical lighting? First, very important thing, it is cleanliness, and also the second one is easy to control, and the third one is it's very economic. Nowadays the CFLs are much improved into LED LCD concept, therefore it is a cheaper one, and also it is easier to handle, easier to control, and also it gives a steady output. There is no kind of any irritation to our eyes, and also it gives a better reliability, and almost it is suitable for all purposes. And you can see the color temperature scale, and the picture will show you the color temperature scale. The north sky, it has 8500 K, but in the daylight flow is 6500 K. So this is called as color temperature scale. How the color is changed depends upon this scale. So halogen, it will give you 3100 K, and cool light, cool white is give to 4100 K, and also the warm white will give you the 3000 K, and even incandescent will give you 2000 K, and HPS gives you 2100 K. And what about the sensitivity of our human eye? As we know that natural light consists of 7 colors having different wavelengths. So these our average human eye is almost sensitive to a wavelength of 5500 in degree ambient. So that relative sensitivity of an eye for a particular wavelength is the visual effect produced by the light on the average human eye as compared with the effect of light having wavelength to our human eye. And what about the sensitivity of human eye? So this is known as relative luminous factor. You can see that graphical information. So the top, it will show you 5500 degree amp. Just And what are the terminologies used in our illumination? Light, luminous flux, lumen, plan angle, solid angle, steradian, candle power, luminous intensity reduction factor, glare, and lamp efficiency. So first we will start with that light. So what is light? The part of radiant energy from a hot body which produced the visual sensation on human eye is called as light. And what about the luminous flux? So the luminous flux is the total quantity of radiant energy per second responsible for visual sensation from a luminous body is called luminous flux. So the total quantity of radiant energy, how much of radiant energy will be dissipated per second is called a luminous flux. And the total quantity of radiant energy per second is the luminous flux. Therefore, the denoted letters are capital F or phi, and it is almost measured in the lumens. So what is called lumen? Lumen is the unit of luminous flux, and one lumen we are defining it as the luminous flux emitted per unit solid angle from a point of source on one candle power. And what is called plan angle is the another terminologies in this concept. The angle subtended to a point by two converging lines lying in the same plane is called a plane angle, and also it is measured in the radians and equals to the ratio of the length of the arc to its radius. Now you can see what is called arc. So it is measured in the theta, that is the plane angle. The unit for that is theta, that is equal to arc. You can see that arc, and also you can see the radius. So you have to take the ratio of the arc and radius. In radians is called plane angle. Next one is called as solid angle. So the angle separated by the partial surface area of the sphere at its center is called as solid angle. It is measured in steradian and equal to the ratio of area of surface to the square of radius of the sphere. You can see that omega, that is equal to area of surface divided by square of radius. Therefore, the omega is directly proportional to the area of the surface, and also it is inversely proportional to the square of the radius. And of course, the unit of the solid angle is steradians. And what is called steradian? So steradian is the unit of solid angle, and one steradian is defined as the solid angle that is subtended to at the center of the sphere by its surface having area equal to its radius square. Therefore, omega equal to surface area divided by radius square, that is equal to 1 steradian. And what is called candle power? So the light radiating capacity of a source is called as candle power. It is nothing but its capacity about that source. So the number of lumens given out by a source per unit solid angle in a given direction is called as candle power, and also it is denoted by Cp. So how much of flux is emitted per surface? That is equal to 1 Cp into solid angle. Therefore 1 into 4 by, it will give you 4 by lumens. That is the total flux emitted. So we can start with that total flux emitted from a body is equal to 4 by lumens. So what is called the luminous intensity? Intensity, otherwise we call it as strength. So the luminous intensity in a particular Direction is the luminous flux emitted by the source per unit solid angle in the direction. It is denoted by letter I and its unit is candela or candle power. So the luminous intensity of a source in a particular direction, that is I is equal to psi divided by omega. So this is a formula for finding luminous intensity. And next you can see the reduction factor. The reduction factor of a source of light is the ratio of its mean spherical candle power to its mean horizontal candle power. Therefore, the reduction factor formula is MSCP divided by MHCP. And what about the illumination? It's a very, very important definition in this unit, illumination. So when a light falls on a surface, it becomes visible. The phenomena of the light falls on surface is called as illumination. So it is defined as the luminous flux falling on a surface per unit area. It is denoted by capital letter E, and also it is measured in lumens per square meter or meter candle. So E is equal to flux per area in lux. Unit is the lux. And next you can see the lux. Oh, what is the definition of the lux? So 1 meter candle or lux is defined as the illumination produced by a uniform source of 1 cp on the inner surface of the sphere of radius of 1 meter. And the glare is the very important thing in our industrial side. So in our human eye, it is very irritating us. We can clearly visible that objects. So in the human eye, the opening of pupil is controlled by its iris, which depends upon the intensity of the light received by the eye. If the eye is exposed to a very bright source of light, the pupil of the eye contracts automatically in order to reduce the amount of light admitted and prevent damage to the retina. So this effect is called as glare. So we have to avoid that. So the glare is defined as the brightness within the field of visible character so as to cause discomfort and interference in the vision area. And what is lighting efficiency? So the lighting efficiency is expressed as lumens output per wattage input. It ranges between 4 and 150 lumens per watt. And what about the lamp efficiency? It is defined as the visible radiations emitted by it in lumens per watt. Usually, the light sources do not radiate energy only in the visible spectrum. So the radiant energy is also accompanied with infrared and ultraviolet radiations. Sunlight produces majority of the radiation in the visible spectrum. The tungsten lamp produces small radiation, so it is not visible, and also the thing is very, very poor. And the lamp efficiency, so already we have seen that the efficiency of fluorescent lamp is more than the tungsten lamp, because you can see that graph, the ultraviolet, visible radiations, infrared radiations, and gas filled, you can see that graph. So 5500 is the very good range for that. And the reflection factor, so whole of the light incident on a reflecting surface is not reflected, some portions only reflected, and other portion it is observed by the surface. So the ratio of the reflected light to the incident light is called as reflection factor. Now you can see the what are the units and what are the symbols supposed used for the luminous flux, luminous intensity, illumination or illuminations, luminous and brightness, and luminous of existence. So these are all the very important introduction to the illuminations. Thank you.